Okay, 8 o'clock has rolled around, so I'm going to go ahead and get started, everybody. Can you hear me okay? Is this coming through all right? First of all, if you're having trouble getting into the college's website this morning, I don't know what the problem is, but it seems to be restricted to Pruitt campus. I seem to be able to log in from my phone, okay, but for some reason around here, the campus is having trouble. So I'm not sure how that's going to affect you as your classes go on, but it won't affect us in here today. First, this is our last section that we're going to cover of new material before we do a review on Wednesday. I'm putting together a review for you right now that should prepare you for the test. I'm going to try to hit one of each type of problem on the test, but there's also a review in My Lab Math out there and it's a good one. It's 40 questions and it covers everything, okay? I strongly recommend that you do that review. Do that test review, okay? And then make sure that you're here Wednesday and we'll cover this one. I'm trying to decide, we may even cover it like a little mini test or something so that you can come in and practice taking these questions. It just depends on how much time I have. So first, this last section is covering something called the quadratic formula. Now, when you're factoring, I mean, the best way still to solve a quadratic equation is not with the formula because it's so prone to error, but it is with factoring. If you can factor a trinomial, then that is your best way to solve a quadratic, something that has a square root x squared at the beginning of it, okay? But if you can't, if it does not factor, if it's prime, then the quadratic equation is your second option. And basically, you just have to memorize this equation. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't know how you remember that, but when I was growing up, we put this to a song, and sang it. And still, I'll never forget the quadratic equation because I kind of learned to sing it. Do something so that you have memorized that quadratic equation, okay? That's something you should know when you come in here. If the first thing you do when you get your test paper is write down the quadratic equation, that's okay. Do you understand what I'm saying? I mean, if you just think, okay, I'm going to remember it for like 2 minutes until I can write it down, then write the quadratic down first thing because you will need it on this test. But basically, the quadratic equation is saying we have a trinomial, an A term, a B term, and a C term. We are already familiar with that. The A, B, and C in the quadratic equation are really relating to the numbers in front of those three terms, the coefficients. Now, this is assuming that you have already factored out the GCF. Don't skip that step because you will miss the problem. Everybody with me on that, right? So we've already factored out the GCF, and of course this one doesn't have one. But you look at the A term and you see that A doesn't have a coefficient, so A is equal to 1. In this particular problem. And then you can find B. Don't forget the signs. Whatever sign is in front of that number, you've got to keep it with the number. So B is a negative 5. And for this one, C is equal to a positive 5. So I've identified the A, B, and C in the quadratic. Now let's just pretend I know that this one's not going to factor. On your test, it will tell you solve the equation using the quadratic equation. So you don't have to try factoring something that's going to come down to prime, okay? So the next thing I'm going to do is I'm going to fill in the blanks. I'm going to say x is equal to negative b. Well, that's a negative 5. Now, I've done the quadratic equation for many, many years, and I still write this down because if I don't, I found out that I have a tendency to mess it up. So I'll say negative and whatever that is in parentheses. I'll fix this later. And then I say plus or minus because there will be two answers. There will be a positive answer and there will be a negative. I'll have to use one of each because I'm taking the square root of the next part. Now that's going to be b squared. If it's negative, include it in parentheses and square it, b squared, and then a minus 4 times a times c. All of that is under the radical, and all of this is over 2 times a. All over 2a. Okay? Everything over there is a fraction. So now let's start to simplify this thing a little bit. I'm going to I didn't leave you enough room to write, and I apologize. We're just going to kind of make do here. This is negative negative 5, which is a positive 5, plus or minus, and then when I've got the square root of negative 5 squared is negative 5 times negative 5, or positive 25. And then I'm going to multiply these three terms together. I'm going to say negative 4 times 1 times 5. Well, really, that's going to be a negative 20. And all of this is still over 2 times a, which is 2. Okay? All right, let's take it a step further. I'll come over here. I'm going to say this is x is equal to 5 plus or minus the square root of 5, and that's divided by, all divided by 2. Now at this point, this is where most of you want to grab your calculator and find out what the square root of 5 is, because this is not a perfect square, but you're not doing that in these problems. We're simply simplifying that radical to its lowest form, leaving it in radical notation if we have to, and there's no factors inside 5 that are perfect squares. So square root of 5 is as simple as it gets. Outside of this, we have 5 plus or minus the square root of 5 over 2. The only way this 2 would reduce is if each of these two terms, and notice there are two terms here, okay? Each of these two terms had a coefficient that would divide by 2. Well, 5 won't divide by 2, and this has a coefficient, you're listening to me, right, of 1, right? What's in front of that square root of 5? A 1. So this is its simplest form. So you really have two answers. You have 5 plus the square root of 5 divided by 2, and you have 5 minus the square root of 5 divided by 2. Now I left room here, and my plan was to proof these for you and show you that that works. X could equal this one, and X could equal this one. But it gets really long, and that paper I gave you is not enough room in it. And I'm not going to proof all of these for you, but I am going to proof one of them for you, and I'll do this one, okay? What do you do when it says proof it? Well, you take the answer and you put it back in the equation as x. And some of you are already going, well, that's way too hard, right? Well, the math is a little cumbersome, but it's not way too hard exactly. Let me see if I can do it for you here. The equation was x squared. Can you see that? Okay, so what was the equation? X squared minus 5x plus 5 equals 0. So if we plug in x was equal to plus or minus, what was it, 5 plus or minus? Yeah, 5 plus or minus the square root of 5 over 2. If we plug in our two answers for x and we solve it, I mean, one at a time, then what we should come up with is 0 is equal to 0. And the math is, like I said, a little cumbersome. Here's what you'd be doing. I'm going to take 5 plus the square root of 5 first. I'm going to say 5 plus the square root of 5 divided by 2. That's my x. So all of that would be squared. And then I'm going to say minus 5 times x. Well, here I go again. 5 plus the square root of 5 over 2, and then I say plus 5 has to equal 0. Well, the first thing that I've got to do is that exponent. You know what? I've just got to raise these things to the power of 2. So when I say 5 plus the square root of 5 times 5 plus the square root of 5, it's going to look like this. And when I say 2 raised to the power of 2, it's going to be 4. You understand? Now over here, I really don't have that same issue. I could, at this point, just copy all this down. I don't have to raise anything here to an exponent. I'm giving myself some space because I'm going to have to come back and clear these fractions. Okay? It's already gotten bad, hasn't it? And I look at my two fractions, and basically they are least common denominator of 4, right? So I'm going to multiply each term in this equation by 4. Well, this is one term, this is one term, this is a term, and this is a term. There are 4 of them. Make sure you see what I'm saying. So I'm going to sum over here, and I'm going to go times 4. Well, it'll be 4 over 1. And then I'm going to say over here, I'm going to go, well, it doesn't matter which way I write it, times 4 over 1, times 4, times 4. Everything multiplied times 4. When I multiply this first term times 4, the 4's will cancel, and all I have left is this, which I really don't feel the need to write down for you right now, okay? That numerator is all that's left. Okay, look at this one. I'm going to reduce it. This is a 1, this is a 2. Okay, I'm good there. And I can multiply through. Now let's see what we have when we simplify this even further. We're going to say this, I have to FOIL it to simplify it. Everything else turned into 1s, didn't it? This is a good practice to see if you know what you're doing with your algebra, guys. The next class gets considerably harder. You should be able to do this, okay? If you're planning to go on to college algebra, you really want to be able to do this. So don't look at it like it's a wasted exercise for you, okay? So 5 times 5 is 25. And then I go outside. 5 times the square root of 5. Well, that's going to be 5 times the square root of 5, isn't it? And then I go inside. Another 5 times the square root of 5. And then I go square root of 5 times the square root of 5. Well, that's going to be just plain old 5. All right. Now I'm going to say minus. Well, over here, what have I got to do? Well, I'm going to go ahead and multiply these. I'm going to say this is negative. Really, it's 10 times 5 plus the square root of 5, isn't it? And this is going to be plus 20. And this is going to equal 0 again. I think I've done it all right. Okay, so here I can simplify still further. Over here I can put these two square root of 5s together, can't I? And I can also put this 20 and this 5 together. I'll simplify a little bit as I go. 25 and 5 is going to give me a 30. And then if I add 5 times the square root of 5 plus 5 times the square root of 5, I get 10 square root of 5s, right? And over here, I'm going to have to distribute a negative 10. So when I say that becomes a negative 50, and this becomes a negative 10 times the square root of 5 plus 20 equals 0, right? Step 1, little baby steps is all I'm doing to solve this equation. So look, I've got positive 10 square root of 5s, don't I? And negative 10 square roots of 5s. Isn't that 0? So those are gone. Thank goodness we got rid of the square roots of 5. Then all I've got left is numbers. All you have to do is say, is 30 minus 50 plus 20 equal to 0? Is it? Yeah, this one checks. You do the same thing for the negative. Okay, what I'm trying to show you is that you can proof these things. And as an exercise, anybody here planning to go on to college algebra? All right, then you should do it. You should do a few of them, okay? You need to know how to do this. Your algebra skills should have reached a point where you can do this math. I know it's tedious, and I know it might take some work, and you might mess up the negatives a couple of times, but this is a good practice, good exercise for you. Is this on the test, is what's in the front of most all your mind. How many want to know the answer to that question? Is this part proofing on the test? Proofing is not on the test, okay? But are you getting ready to go on to the next class? That's my first question to you, okay? I mean, because most of you, if you're taking this class, it's because you need college algebra. All right, right? Isn't that why we're here? Everybody good? Okay. All right, let's go on. I'm not going to go through too much more with it, but I do want to go through this. We got another quadratic down here. It does not factor, okay? It doesn't factor in our normal format, so we're going to use the quadratic equation. We're going to identify A and B and C. And then we're going to fill it in. Go ahead and you do your equation, fill it in real quick, and then I will show you what it is, and so you can make sure you haven't made any mistakes before you start solving it, okay? Go ahead and use this area for proofing down here because we're kind of done with the proofs today. All right, if I'm putting it in the quadratic, I have negative b plus or minus the square root of b squared minus 4 times a times c. All of that is under the radical, and all of this is over 2 times a. Now I start just doing the math. I say that's equal to negative 2 plus or minus, and under this radical, I can say that's 4 minus 20, right? And all of that is over 2. Everybody good so far? Have you gotten that far with it? All right, so let's come up here and say x is equal to a negative 2 plus or minus, under my radical, I'm going to have a negative 16. Now, don't start reducing things under the radical with denominators in your fraction, okay? I've seen people look at this type of problem, get to this point and go, well, everything divides by 2. And at that point, you cannot divide everything by 2 because this is under the radical. It may be even, but it's still under the radical. It's not a 16, it's the square root of a negative 16, okay? So it's different. Now look, we know the square root of a negative 16 is really not a real number, so we're going to have to pull an imaginary square root of negative 1 out of that, right? So what we really have here is x is equal to negative 2 plus or minus, and I'm going to split it. I'm going to say that's the square root of negative 1 times the square root of 16. I mean, you can put it right under one radical if you want to, all over 2. I happen to know that this is the imaginary number I, right? And this is 4, isn't it? So I can go on down here and I can say, well, that's equal to a negative 2 plus or minus, and what it is I times 4, which we would write as 4I, wouldn't we? Now you can reduce the thing, okay? Because you have 3 terms. Some of you need to really be paying attention to this one. 3 terms. This term, plus or minus, separates another term. So I've got a coefficient of the term. I've got a 2, or negative 2. I've got a 4, and I've got a 2. I've got something that both of these numerator terms will divide by that denominator, right? So I can divide them all by 2. I'm going to say negative 2 divided by 2 gives me a negative 1. 4 divided by 2 gives me 2. And 2 divided by 2 gives me 1. So I don't have a denominator anymore. That's my answer. Negative 1 plus or minus 2I. Could that be put back in there and proved? Yes. And it would work. I did it last night. I was bored. Okay? All right, let's see where I'm going from here. So far, any questions? Are you okay? Are you good with this? All right, let's keep on going with this quadratic. I've got a bunch of them for you, but I really want you to have practice plugging these into the equation. The one thing you have to remember before you can use the equation, the quadratic, is it has to be in the format trinomial equal to 0, okay? This one is not. I have 7x squared minus 2x equals 10, and it can't be. It needs to be equal to 0. So you're going to do the same thing you've always done. You're going to subtract 10 from this side, subtract 10 from this side, and you're going to rewrite the thing. This one becomes 7x squared minus 2x minus 10 equals 0. Now, in that format, that me writing that minus 10, do it however you need to do it so that you don't make a mistake on it, okay? I just kind of abbreviate it now. Why did I subtract 10? Because I want to go over here to where my highest exponent is, my x squared. I want to keep that the side that doesn't have, that's not 0. I want everything to go to that side. Now I have the quadratic, and I can say a is equal to 7, b is equal to a negative 2, and c is equal to a negative 10. If you wrote it down, did you get the negatives? Make sure you do, okay? And then I'm going to say, and here truly I apologize, there's not enough room on this paper for quadratics. I should have giving you more room. X is equal to negative b, which is a negative negative 2, plus or minus the square root of b squared, well that's negative 2 squared, minus 4 times a times c. Okay, all over 2 times a. All right, I've got a lot of math here I can do. I'm going to say x is equal to, well that's going to be a positive 2, plus or minus, and under this radical, let me just see if I can get it simplified. Negative 2 squared is positive 4. And this is a negative times a positive times a negative. I know I'm going to end up with a positive. And I've got 4 times 7, which is 28, times 10, which is going to give me 280. All of this is going to be divided by 14. Once again, running out of room, I know. All right, so let's go over here. This gives me x is equal to, that's right, isn't it? Plus or minus, whoops, forgot the 2. 2 plus or minus the square root of 284, and it's divided by 14. Now at that point, you've got to look at the 284 under the radical and say, are there any perfect squares inside 284? A good guess would be, will it divide by 4? Okay, that's the smallest perfect square I can think of. Will 284 divide by 4? And at that point, then all you really have to do is take your calculator and say 284 divided by 4. Yep, it will. And it comes out to be 71. So I know that this is really equal to 2 plus or minus the square root of 4 times 71 all over 14. And I know that the square root of 4 is 2. So now I can simplify this thing again. Here I go. I'm going to move down here. This is equal to 2 plus or minus, that 2 would be multiplied times the square root of 71, right? All over 14. And at that point, somebody tell me, are we done? What can you do? See, there's nothing you can do with that radical. Square root of 71, there are no factors. 71's prime. If you try everything you can want to, it's done. So I'll tell you that much. But what, say it again? Yeah, you see a 2, don't you? This one is even. There's a 2 here and a 2 here, and that's even. So we've got 3 terms that will all divide by 2. We have to do that. We can't leave it like this. 2 divided by 2 is 1. 2 divided by 2 is 1. When it's in front of something, I don't have to write it down. 14 divided by 2 is 7, and there's my answer. 1 plus or minus the square root of 71 divided by 7. Okay? Don't forget to reduce it. But you can only reduce it if all the coefficients will reduce with the denominator, okay? They have to all have a common factor. You also have to get that common factor, you have to get all of the square roots out from under the radical, okay? All right, next one. This one looks really bad because guys, it's just on the wrong side, isn't it? Isn't everything on the wrong side? But basically, I want to get this negative 4 over to the side with the x squared term. So what I'm going to do is I'm going to add 4 to both sides of this, and I'm going to end up with an equation that looks like this. It's going to say 0 is equal to 4x squared plus 3x plus 4. Now, you're okay. It doesn't have to be, the equation we're working doesn't have to be on the left side or the right side. Just as long as 0 is on one side, you're fine, okay? So we can work this just like everything else. We say A is equal to 4, B is equal to 3, and C is equal to 4. Now, I'm going to let you work it, okay? Go through there and tell me, go as far as you can go. If you get stuck, you stop. If you need more room, I brought blank paper and put some out here on the desk. If you don't have any with you and you want some more room to write, come get some, okay? Did everybody get that far? I've got all the way down to where I put in the numbers for A, B, and C, and then I've simplified under the radical, and now I'm going to take it to the next step. You should have gotten that far, no problem, right? Any questions for that? So now I've got -3 plus or minus, and under this radical, when I say 9 minus 64, I'm going to come up with a -55. And all of that is going to be over 8. And that's where I stop and say, okay, I'm going to have to pull out an I, right? Square root of -1, so you shouldn't really probably have to write this anymore. This is going to equal -3 plus or minus, and I just know what it's going to be, so I'm going to say the square root of -1 is I. What's left under the radical is 55. Down here is an 8. And I look at 55 to see if it will simplify. Anybody see any perfect squares inside 55? The only two factors of 55 are 5 times 11. No squares, right? If you tried to factor it, you'd see that. But that's it, as simple as it gets. -3 plus or minus I times the square root of 55 times over 8, okay? Okay, are you okay so far? Can I say thumbs up if you got that one? Did you get that one? Did you have trouble with it? You good? Okay, moving on then. Your favorite fractions, what do? The first thing you do every time you can do it as a first step is clear the fractions. I have two fractions, both have a denominator of 5. I will multiply all the terms in that equation times 5 and clear the fractions. I'm sorry it's not big enough to see it. This one times 5, this one times 5, this one times 5. And when they're fractions, I usually write them as 5 over 1. So you can see that they cross-reduce, right? This becomes x squared. This is 5x, and this one is equal to 8. And now you can clearly see your next step, can't you? I need everything to be on one side of my equation. I'm going to go to the side that has the x squared variable already there. So this thing is going to be subtract 8 from both sides, right? However you want to write it. X squared minus 5x minus 8 is now equal to 0. And now it's in a form where if they didn't tell me to solve it as a quadratic, I would try to factor it. But I can't, so I'm going to go A is equal to 1, B is equal to a -5, C is equal to a -8. You should be able to finish this one up, no problem. Okay, did you get here? All we had to do was say negative 5 squared is 25, minus 4 times 1 times negative 8, well, that's two negatives multiplied together is going to give me a positive 32 divided by 2. And when I simplified this, 25 plus 32 gave me the square root of 57. At first glance, that doesn't look like anything, but what you really should see is that that is divisible by 3, right? Okay, I can add the digits. 5 plus 7, I get 12. 12 is divisible by 3, so 57 is divisible by 3. So my thing is, well, I better try it, because there could be a square root in there, a square that I don't recognize. But it's not. It's 19. So 19 times 3, okay, no perfect squares, right? And you know 19 is prime. So at that point, you know you're done with under the radical. You look outside at 5, 2, and a 1, nothing's going to reduce. Do you understand? So you're finished with that one. Let's do the next one. You should be able to do this one, no problem. And the next two, well, actually, you should be able to do all three. Why don't you start working and see if you can finish up this page. So if you want to look at your answers, if you want to see the check your answers or check the solutions to 6 and 7, they are there. Okay. Okay. How are we with these? Okay? Good? Okay. When I just want to go over something really quick. When this 184 showed up under the radical, what I did with it is say, can it be divided by the smallest or one of the radicals I know, one of the roots is 4. So I tried that, and I thought, okay, if it will, and then I got 46. And then I tried dividing 46 to see what, any perfect squares came out of 46, and the only thing I get is 2 and 13. Well, those don't work, so I'm stuck with 4 times 46, okay? 4 is a perfect square, so it does simplify a little bit. That comes out to be, that's how the 2 came out from under the radical, okay? And how I knew not to go any further with it is because I checked. There are no more perfect squares inside 46, and you must do that, okay? Yes?
Could you do that with the 25 right there?
25.
On number 7?
Well, you can't because it's added to, you got to add 8 to it.
Oh, okay.
So you really don't have 25, you have 33. So 25 is not a factor under there, it's 25 plus 8. There's no perfect squares in 33. Okay? Good question. Anything else, guys? It's confusing when you see a perfect square sitting under a radical. That's the first thing you do want to do. Okay, I want to do something with you because all of these are ending up with weird answers, aren't they? Fractions with radicals in them. But what happens if everything simplifies? Look at this problem, and this is where you're going to need an extra piece of paper. So I hope you have something to write on. I want to show you one that is a little bit different. And just because it's y, we don't care, right? You don't care whether it's y or x or q or smiley face, right? So what I've got here is 2y squared minus 9y plus 4 is equal to 0. Well, a in this thing is equal to 2, b is equal to a negative 9, and c is equal to 4. It was fortunately in the right format. So when I plug it in, I've got x is equal to a negative b, which is a negative 9, right? Plus or minus the square root of b squared, which is negative 9 squared, minus 4 times a times c. This should be really old hat by now. All divided by 2a, 2 times 2. So I'm going to keep going here, and I'm going to say, well, this is x is equal to a positive 9, plus or minus, and under this radical, I have negative 9 squared, which is positive 81. And then I'm going to say that's a negative times a positive times a positive, so it's going to be a negative, and that's going to be 8 times 4, or 32. So I've got 81 minus 32. Everything here is going to be divided by 2 times 2, or 4. Okay. Now I get x is equal to 9 plus or minus, and 81 minus 32 comes out to be 49. And at that point, you should see, well, that radical is going to disappear, isn't it? This is the perfect scenario for solving. I don't have to leave it in a weird format. What this ends up being is 9 plus or minus 7 divided by 4. Now, you don't leave it like that. This is why I wanted to take you through this problem. You can keep going. You're not stuck with a radical that you can't add to something. You can say, one of my answers is going to be 9 plus 7 divided by 4. The other answer is going to be 9 minus 7 divided by 4, right? That's easy math. So I say 9 plus 7 divided by 4. Well, that's going to give me 16 divided by 4, isn't it? And 16 divided by 4 is 4. One of my answers is right there. The other one is going to be 9 minus 7, which is 2 divided by 4. I can reduce that to 1/2. My other answer is right here. So you're not always stuck with something under the radical that will not reduce. Will not simplify. And when it does simplify, you finish the math. Don't leave it here just because you're used to leaving it here, okay? Go ahead and finish the math. Create the two answers. One is going to have a plus, the other one's going to have a minus, and you're going to come up with a single number for each of them. Are you good with that? There wasn't one in your examples like it, and I thought you should see it, okay? Because you may have one like that one on the test. All right, let's go on now to the next section. Yeah, I think it is a new section, right? And let's talk about this. We are going to be solving equations that have radicals, and we're going to do this solution where we get the radical on one side, the square root, the cube root, whatever, and then everything else on the other side. The way we're going to solve it is we're going to take the side that has our radical to whatever power it needs to be. The reason, and then you're going to have to do the same thing to both sides. The reason we can do this is if you do the same thing to both sides of an equation, you haven't changed the value of it all. So if I square both sides, I'm okay. If I cube both sides, I'm okay. And I can solve things by getting the square root over here of 5x is all by itself, and then I've got 25 on the other side. So how would I actually get the answer to this? Well, to get rid of this radical, I'm going to square it, which means I have to square the other side too, right? So what I have to say is 5x, square root of 5x times the square root of 5x gives me 5x. Everybody understands that concept, right? You good with that? If I multiply two square roots by themselves, I get whatever that the root is. Okay, so next I'm going to say 25 squared. Well, 25 times 25, you would probably type into your calculator because we're not used to squares that high, but it's 625. Now how do you solve this? What am I going to do? Divide by 5. 5x divided by 5, 625 divided by 5. So x is going to equal 125. But look what it says. Be sure to check, because these don't always work, okay? You might find it, and then because of a negative or something, this isn't always going to work. So you'd have to check every time you do this. You have to take this 125 and plug it back into the original. You have to say the square root of 5 times 125, that was the x, is equal to 25. Well, that's the square root of 625. Is that equal to 25? When you take the square root of 625, guess it is. We've already kind of proven that. What you end up with is 25 is equal to 25, and it checks. So that's just a good answer. X is really equal to 125. Don't forget that step, though. You do have to check these. Not all of them will work, okay? The next one. Well, this is a weird radical because it's not just got one term under there. It's got two terms, and you don't care. You're going to take this entire thing and get rid of the radical by raising it to whatever index it has. Well, square root has an index of 2, but you got to raise the other side of that equation to the same thing. When I do that, the radical disappears, and I have x minus 1 is equal to 4 squared, which is 16. And when I solve that, I have x is equal to 17, right? And then I plug it back in. I go square root of 17 minus 1 is equal to 4. You probably can see this already. Square root of 16, is that equal to 4? Yeah, so this is a good answer. Okay, next, we're going to be squaring the 3x over here, and don't forget, everything there has to be squared, including that negative out front, okay? So I got to square a negative 12. Okay, I got 3x is equal to negative 12 times negative 12 gives me a positive 144, right? I divide both sides by 3, and I come up with x is equal to 48. And I plug it back in. Square root of 3 times 48 is equal to negative 12. Look at this equation. Is the square root of a number ever going to equal a negative? Never. This one doesn't have a solution. This one didn't work. Do you understand why? The square root of this number is never going to be negative. Right? No solution. So our answer, x is equal to 48, did not work. That's why I'm telling you, you have to check every one of these, okay? They're quick to solve, but the solution involves checking. All right, this one. The problem with this number 4 we've got down here is that there's more on that side than just a radical. And we need it to be the radical on one side, everything else on the other side. So I'm going to add 4 to both sides to get rid of that minus 4. So that I will have my radical of 3x minus 2 equal to 5. And then I can square both sides to get rid of the radical. I end up with 3x minus 2 equals 25, which is easy to solve. I add 2 to both sides. I have 3x is equal to 27. I divide both sides by 3, and x is equal to 9. I plug it back in. 3 times 9 minus 2 is under the radical. Minus 4 is equal to 1. That's what it has to equal this time, okay? So I've got the square root of 27 minus 2 minus 4 equal 1. Well, that's the square root of 25 minus 4 equals 1, and that is 5 minus 4 equals 1, and I am happy, right? I may be going a little fast, but this is easy math at this point, right? Pretty simple math. think we just have one more page. I think I've just got 4 more of these examples that I want you to try. And I've got some cubes in there. So let's do one more of these together, and then we'll do some cubes. Okay, this one, you should be able to take it all the way through. Why don't I give you a couple of minutes to try it, okay? Remember, everything else on the other side, radical all by itself on one side. And then you can raise it to whatever power. The index of the radical, which is a 2 if it's squared. Okay, when I got everything else to the other side, I ended up with the square root of 8x minus 7 is equal to 5. And I'm going to square both of the sides of my equation to get rid of that radical. I now have 8x minus 7 is equal to 25. I add 7 to both sides. I have 8x is equal to 32. And I divide both sides by 8. And I end up with x is equal to 4. How are we so far? Good? Now, plugging in for x, I end up with 8 times 4 minus 7 minus 5 is equal to 0. And that's going to be 32 minus 7 minus 5 is equal to 0. And that's going to be the square root of 25 minus 5 is equal to 0, and the square root of 25 is 5. And that is how I know it worked. Are you okay? Good? Are you ready to tackle cubes then? So with squares, we squared both sides. With cubes, we're going to cube both sides, all right? And with cubes, you have to make yourself think a little more because you're not as used to cubes as you are to squares. But here we have the cube root of 30x is equal to a negative 6. Negatives don't play the same way as, negatives with cubes don't play the same way as negatives with squares. There is a perfect cube root of a negative number. A negative times a negative times a negative times a negative times positive times a negative times a negative times negative will give you a negative. So you can get a cube root of negative where you can't get a square root of a negative. You understand what I'm saying? So you have to watch the negative thing with the cubes. And this one, we have to take it both sides to the power of 3. When I do that, I got rid of the radical. I now have 30x on this side. And I have to pay attention to my negatives. Negative times negative is going to give me a negative number. And 6 cubed is 216. I don't know if you memorized those cubes like I told you to memorize some of them, but you could easily go 6 times 6 times 6 in your calculator. Just don't forget the negative, okay? And then I'm going to say, okay, divide both of these sides, divide them both by 30, right? It's not going to be as pretty as I want it to be, is it? But I end up with x is equal to a negative 216 divided by 30, and that's going to simplify down. I could divide both of them by 3. I know I can. I end up with a negative. It's a negative number, 108 over 5, 15. Sorry. Right? And then I'm going, well, wait a minute. 108 is it'll divide by 3 again, won't it? So I kind of keep going. Okay, if I divide that by 3, I've got 36. And divide that by 3, I've got 5. So I kind of reduced it twice to get there. The reason I did it is because not many of us are going to see that 216 divides evenly by a 6, right? So you just take it one step at a time. Oh, and got 10. How did I do that? You are so right. I'm stuck there, aren't I? And now it'll divide by 2. What am I, 90? What'd you get? 54? Did I divide that correctly now?
I think 108 is supposed to be 72.
Okay, how did I mess this one up so badly? Stretch this out and let's go down here and do it. So dividing 216 by, what'd you divide by 3? And you're going to divide both of them by 2 this time. 36 fifths. Is that better? Yes? Thank you, guys. Okay, so somehow I ended up with negative 36 fifths in my answer also, but I went a different way and got it. Okay, well, we're going to ignore that for now, okay? I just made a mistake working with you. Did I do it again?
Why can't you divide negative 216 by 30 and get negative 7.2?
Well, you don't want a decimal, okay? You don't want to deal with a decimal in this. You'd really rather keep them as fractions. I guess if you wanted to and you'd rather work with decimals, you could. You'd rather work with the decimal than the fraction. But with the fraction, it's sort of simple to do the math under the radical with it. What I came up with is this. It's the cube root with checking it. The cube root of, what did I have? 30 times a negative 36 over 5, right? And this thing is going to reduce away. The fraction is going to go away right away, okay? So when I come up here, I've got is equal to negative 6, right? Isn't that right? And so when I take this, I've really got 6 times a negative 36, which is the cube root of a negative 216. And if you're dealing with a decimal, okay, it might be a little harder to do, but it's usually easy to reduce it with the fraction if you keep the fraction. And if you get a simple decimal, I'm not going to complain if you keep it, okay? All right, so when I do this, I've got the negative answer to my cube root is right, isn't it? Okay, good. Next one, you want to try it? You're going to have to get the negative 3 to the other side. I'll just tell you that first thing, okay? So you're going to have to add 3 to both sides, and go ahead with it. I'll try and write it up here. And I'll try and do it right this time. Okay? This one's a lot simpler. X came out to equal 28. So when I look at it, I've got the cube root of 28 minus 1 minus 3 is equal to 0. And that's going to be asking me for the cube root of 27. And 27 is a perfect cube, sorry, cube root. 27 is a perfect cube. 3 times 3 times 3 is 27. So what it's really saying is 3 minus 3 is equal to 0. Everybody good with that one? It's always easier when it doesn't end up as a fraction, right? Okay, are you okay with the cubes? The last one you should be able to do no problem. It's back to squares. So go ahead and finish that one. It looks very much like the ones we've already worked. And your answer, when you get finished with this one, x is equal to 9, okay? Good? Okay, excellent. Okay, there's a solution if you need it. Your test on Monday has 20 questions. And because there are only 20 questions on the test, they count more. So what I will be doing is looking for opportunities to give you partial credit. All right? Because I hate counting off just because you miss one little thing. I hate counting off 5 for each problem that you don't get the correct answer. But what this means to you is that you have to give me step by step. Everything that you do has to be written down clearly so that I can read it. If I cannot read it, I cannot give you partial credit. And sometimes you guys have a tendency to do things in your head and not write them down. I cannot give you partial credit for that either, okay? So get in the habit this week as you're studying and getting ready for that test of writing these things down. Go step by step, make it clear for me, and I will see you on Wednesday for your test review.